This is the chapter closure for Integrated Math 1. It says Chapter 1, but it should say Chapter A right there. Write an expression for the tiles as they appear. So over here, I have 2x minus x plus 3 minus 2, and then down in the subtraction area, I have an x, a minus x, a plus 2, and a minus 1. So I simplified it, and I got x plus 1 minus 1, which is just x. For question 102, it says write the expression for each side of the expression comparison mat. Use legal moves to simplify and determine which is greater. So on the left, there were 2 x's up in the positive region, 3 units, and -1. Down in the subtraction area, there were 2 x's and -2. So I simplified that to 2x, combine those two to get 2, minus 2x, and then subtracting a negative would be plus 2. So 2x minus 2x is 0, and 2 plus 2 is 4. So I have 4 on the left. And then on the right, there was a 2x, a negative x, positive 2 units. Down in the subtraction region, there's a 2x, a minus x, a plus 1, and a minus 2. So I simplified by combining these two. Let that alone for now. 2x minus x is just 1x, so minus x, minus, and that would be a -1, so it's plus 1. X minus x is a 0 pair, so 2 plus 1 is 3. So if I compare your 4 and your 3, the left side is greater. Moving on to question 103, simplify each expression with or without your algebra tiles. So on part A, I looked for like terms. Well, first I actually distributed that -2. So I did 3 plus 7x minus the 2 minus 9x. So 7x minus 9x is -2x, and a 3 minus 2 is 1. And then these are not like terms, so they cannot be combined. I did the same thing over here, distributed that negative out. So I got 6 minus 3x plus 4. Then this plus 7x minus 11, look for my like terms. So a -3x plus 7x is positive 4x. A 6 plus 4 is 10. 10 minus 11 is -1. Jumping down to question 104. It says follow the order of operations to simplify each expression below. So the order of operations is parentheses, exponents, multiplication and division, and then finally addition and subtraction. So for part A, I simplified in the parentheses first. 5 minus 4 is 1. And within this parentheses, I did the exponent first, which is 2 squared, which is 4. 8 minus 4 is 4. 2 times 4 is 8. I squared the 6, got 36. Then I had some division first to do, so 8 divided by 8 is 1. So 36 minus 1 plus 1 is 36. And then part B, I did the parentheses first, so 9 minus 6 is 3. Exponent, 3 squared is 9, so 2 times 9 is 18, and 18 divided by 18 is 1. All right, down to question 105. This time they want you to plug in the 5 wherever you see x, and they want you to plug in the 3 wherever you see y. So I got 6 times 5 minus 3 times 3 plus 7 minus 5 times 3 just by plugging in the numbers. So then I simplified in these parentheses. 3 times 3 is 9. 9 plus 7 is 16. 5 times 3 is 15. So 30 minus 16 is 14. 14 minus 15 is 1. All right, turn to the next page. At the top of page 22, we've got question 106. Simplify the expression by combining like terms. So I just checked mine off as I used them. So I started with the first term, which is 3x squared, looked for any other x squareds. Yep, there's one right there. So I got -5x squared. Then I went to my numbers. So 10 minus 8 is 2. 2 plus 3 is 5. My next term, y squareds. I've got this -y squared and this y squared. They actually are a 0 pair, so you'll notice they don't appear over here. 4x the only term, so I'll leave it alone. And then the last one was your y's, and there's only one of them, so leave it alone. All right, jumping down to question 107. Simplify the expression. Same thing. I distributed first here, distributed that negative sign, then I looked for my like terms, and I checked them off as I used them. So I had a 3x squared and a minus 2x squared, which is x squared. I had a negative 5x, so that's there. I had a negative 4, that's there. I had a plus xy and a minus 2xy, which gives me a negative 1xy. Then I plugged in the values that they gave me. I plugged in negative 1 for x, and I plugged in positive 6 for y. Notice that I use parentheses. That's a good strategy so you don't end up missing the sign. So negative 1 squared is 1. 5 times negative 1 is negative 5, but you're subtracting the negative 5, so I added 5. And then down here I simplified this. Negative 1 times 6 would be negative 6, but you're subtracting a negative 6, so I wrote plus 6. So from left to right, I went 1 plus 5 is 6, 6 minus 4 is 2, 2 plus 6 is 8. Jumping down to 108, solve the following equation for x and check your solution. So I distributed that negative sign out front, so I got 2 minus 3x plus 4. So I subtracted 2x from both sides. I also subtracted 2 and subtracted 4, so I got negative 5x equals negative 15. Divide both sides by negative 5, which makes that positive 3. Then if you plug the 3 back in, you're going to notice that you get negative 3 equals negative 3. Jumping down to question 109, solve each equation, record your work, and check your solution. All right, so for part A, on the left side, up in the positive region, I have a 1 and a minus 2. Then down in the subtraction region, I have a negative 2x. On the right, I have a negative x and minus 3. Down in the subtraction region, I have a positive x plus 2. So I distributed my negative signs. Negative and a negative is a positive, negative right here, negative right there. Then I just combine my like terms. Over here, I have a negative x and a negative x, which is negative 2x. So when I add 2x to both sides, I get 4x. When I add 1 to both sides, I get negative 4 on the right. And then when you divide by 4, you get negative 1. Part B, I have in my addition region, I have an x. And that should be a negative x. Let me add a negative sign in there. I have a negative x plus 1 minus 3, and down in the subtraction region, I have 3 positives and a minus 1. Over here, I have an x, but I also have a negative x. That should be a negative at x, not a minus 1. So I should have a positive x, minus 1, and then down in the subtraction region, I have an x plus 3. So when I go to simplify over here, I should have a negative x minus 2, distribute that negative there. These x's cancel. They are opposites, so they're gone. They're a 0 pair. And then what do we got? We should still have a negative x over here. Okay. And then we should have negative 1. And then minus 3, good. Okay, so if we add an x to both sides, and those x's are gone. These are in opposites, these are opposites. And I should have negative 4, so plus 4. So that should be, oh, this should be negative 4. So I get negative 4 equals negative 4. This is one of those infinite solutions. Man, I wish I had a pencil. All right. And question 110, solve for x. Write down the algebraic result of each step and the legal move you made to get there. So on part A, I subtracted 2 from both sides. Then I divided both sides by -2. Got x equals 5. So if we plug back in 5, we're going to get -2 times 5 plus 2. Let's see if that equals -8. So that's -10 plus 2. And yes, that equals -8. Check. Part B, we got 5x minus 2 equals 5x plus 8. Subtract 5x from both sides. Add 2 to both sides and you get 0 equals 10. That's where you get no solution.